My name is Morten Olavsbråten. I'm from the University of Trondheim in Norway. What we have done here is that when you do envelope tracking of GaN devices, we have tested on a Wolfspeed device, the famous 10-watt device. And if you track maximum efficiency points, you will see a huge spread in the phase distortion of the device. So we have been involved in trying to track different trajectories. And for instance, a flat, this is ideal curves with purely ideal simulation, with a flat gain tracking here down to a certain voltage, you get still a huge phase error. Alexander Alt at Cardiff University discovered that if you do not maximize your gain at the input but have a slight mismatch, you can reduce this phase deviation on the maximum PAE amplifier. So we thought, let's see if that also applies if we have a different trajectory for the drain tracking, like flat gain. So we simulated ideally flat gain also with where we mismatch from the maximum point to, let's say we lose 2 dB, that is okay maybe, depending on the application. We selected 2 dB and that is this area here. And we selected the best one where the phase distortion were much lower, and this is the result. It's almost half the phase distortion. So we tried to prove that in a design where we designed an output network that is the same for both, a modular design, so we can just exchange the input, and we realized this and this point, and then did the ideal measurements, but now in the lab measured the gain curves for different voltages and the corresponding phase. And so where is the flat gain? Of course, it's lower than here, almost 3 dB, so we have some issues with the output network, but we just kept it. And then we saw that you have a huge phase difference here, up to actually tracking from 30 volts down to 12 volts. We have 62 degrees of phase error. But if we use the ones that have lower gain, but mismatched, we have only 22. So it's significantly reduced, which will be much easier for a DPD afterwards to correct, because there are not that high error, and the gain is still flat. And in the practical, here we lose only a dB, not the intended 2 dBs. So maybe that's due to the fact that we have lower overall gain, but tracking exactly to the same voltage range here. And we see that we have also lower phase distortion, even if we use flat gain. And I think this is not a specific Cree device property. We have seen it in other gallium nitride transistors, also integrated MMICs. So I think it's a GaN thing. Okay.